So for Grasshopper, you can model geometry inside it, or you call some geometries you already build it on Rhino. And in order to do that, in Rhino, if you remember from the last time, these are some basic components you can use it. Let's say we will draw a polyline. Can draw some points. In Grasshopper, if you want to call any of these items, so we will start with, let's say, these basic parameters. We call it parameters. You can call points, curves. To call any of these points inside Grasshopper, you just select in Rhino, then right-click on the component and select maybe one point or multiple points. Right-click, select multiple points, and here in Grasshopper you will find that there is a difference in the component color. So this orange color means that it's empty. It doesn't save any geometry or any data. And for this gray one is this means that it has data inside it. And if you hover the mouse on any of these, it tells you what is this component for. So let's say this is a points, and inside this panel it says that there is a one referenced point. It's written within this pop-up menu. So this is curve. I can select a curve, right click, and set one curve. If you draw many, right click, set multiple curves. You can select one by one, and according to the selection, it will be sorted. So this is the first item, this is the second item, this is the third item. Press enter from the keyboard. So this tells you that there is three locally defined values, three referenced polyline curves. And the viewport in Rhino, anything you saved it in Grasshopper or generated it within Grasshopper, you will find its color within these default three colors, red and the green and the blue. So for instance, now this point, when I selected, if I zoom here, yeah, okay, so it's red color. Maybe I will hide this from this panel. Here I made this turned this light off, so then I can see the lines that I draw in Rhino. So the basic color now is red for all of these components. So this means that Grasshopper saves something from the Rhino interface. If you clicked on this object, it turns to green. So this means that this is something you selected it in Grasshopper. If I selected this one, so then I selected all of these. If I draw another one, select one curve. Now you can select any because you already hide it from here. So take care that this synchronization between what you see from these layers, any of these layers, if is it turned off or on, it will affect the selection in Grasshopper. Then so this means, as we said, now we have two types of components in Grasshopper. One, this is the one that we just used it now, this one, and this contains mainly data. You can save it within Grasshopper, or you call it from Rhino, but these components can't generate data. But here, so here also you can find maybe cylinder, polyline, points, but these kind of components has kind of multiple inputs and outputs, and with this you can generate data. So if I went to here, let's say, so all of the menus here has the same interface. All of these components has the same. If you went to do any of the other components in the other menus, you will find that just to click and drag it here, you will find that it has multiple inputs, multiple outputs. So, and also you can reach any of these components, double click inside the canvas, and you can write the name of the component. So let's say now I want to generate a point. So I will write point. This is all of the commands that start with point. I want to construct a point. So this is the one that I will select now. We will use in this course very few amount of components. So let's say now I need to generate a point. It has inputs, outputs, and X, Y, Z. If you hover the mouse on any of these inputs, it tells you what is this. It's the X coordinate of the points. If we return it back to the parameter, one of the most important will be components here. You will use it a lot. This slider, number slider. You can click on it and drag. It will give you a slider, just the output of it, just a number. And the default is start from 0 to 1. If you want a specific range for sliders, you can double click. You can say that I want a slider start from -10. And then this is the larger than or smaller than symbol. And I want to adjust this slider on a specific number, let's say 3. Then the maximum range, let's say, is 30. So this means that it's a 3. The minimum is -10. The maximum is 30. The main connections between all of these components in Grasshopper canvas is just you will click and drag from output to inputs. Okay, you can't drag from here to here. So you have to drag from the outlet, say, of the slider to the input. And you will find here that there is in the canvas, this is I selected, so this is green. So now I can, whenever I move this slider, there is a point moves from -10. So this is the origin point, 0, 0, 0 in X and Y and Z. This is the X axis. And the big divisions of the grid is module 10. So then this is -10. And if you moved it, also you can click, the same slider can be connected to multiple inputs. So now if I moved it, now it moves in X and Y. Any of these components here in Grasshopper, you can make a copy and paste, just like any command, copy and paste. If you want to remove any of the connections, you can press in Mac Command and just drag. This is to remove a connection, or right click on the input and disconnect. You disconnect the connection between these two. So now the points will move only in X. If you connected this like this, so then it will move in this way. Right click, disconnect. What happens if you want to add to generate many points from the same component? So you can start with multiple inputs in X. So let's say now I will click on from the keyboard Shift and press. Now there is 2 inputs in X, and here we will find that in this interface there is 2 points. One for, let's say, this slider, and this is the second one. And also you can make many. Shift, just click Shift and drag. Now I have 3 points. This is with the scroll. You just to make a zoom, right click to make pan if you have a mouse. Now let's see what is the output. So now I know now that the X has three values, and it's written here in this menu. If you hover the mouse on the points, you will on the output, you will find that there is a 3 output values. You can see the output by this panel. We will use it a lot. This component, you drag it. This is just, you can write inside it. You can connect the output of any components to this input. It tells you what is the values or the output of this component. So now I have 3 values, X, Y, and Z for points. For this menu, it will not tell you sometimes what is this data itself. It's just, let's say, it's a list of numbers. So this kind of parameters, you cannot generate with it, let's say, a curve. If you dragged any of this, it tells you, no, this is a component for curves. This is a list of data, of points, or a text. So it will not understand what is this. Here it tells you data conversion failed from point to curve. If you connected these two together, it will tell you data conversion failed from text to curve. So this means that the output that is saved here in this panel. So now the output is null. Let's see what's the output here. So this is the panel. Click. It's unknown. Okay. So as you saw, if you connected something wrong, this means that it's red. It's green means that you selected it, and you will find this object. The default is in Rhino interface, or in the Rhino perspectives of any of the viewports. Gray means that it contains the data. Orange that it doesn't contain any data. Okay, if you hover the mouse on any of these inputs and outputs, it tells you what is this input refers to, or what's the output. Just I highlight the basic things. This is for a connection. As we saw, you can make shift and drag to connect multiple items. Also, you can make this right click and disconnect on any of the inputs to disconnect a specific parameter. Now, a list of data. So now if you want to generate a multiple list of values, so there is a couple of basic components you can use. Series, S-E-R, this series. We can use in this course only two main, a series, double click, and range. So these components, it generates values. This one generates a series of values. The inputs tells you here, if you zoomed, this is the start. What is the first number you want to start from? So say I want to start a series of numbers from, if you clicked 4, it will just generate a slider for you. So now I will start the first value. Here is the panel. Connect. It starts from 4. The n is the step size. So the default is 1. There is some default values in these inputs, but you can change. Let's say I want to 1.5. So this means here is a slider. This is n. So now the steps is 4, 5.5, 7, 8.5, and so on. And this is the count. How many? So now it's the count. The default value is 10. 20. So this generates a list of values, 20 values. And here it tells you, this is, we call it the index. In this pan, this is the index. So the first item, it index 0, 1, 2, 3, 4, and these are the values. So the left is the index of the item, and this is the value itself. And this is a 20 value, so it starts from 0 to 19. I think this is easy. Now, at the moment, these values doesn't generate anything, but if you connect it, let's say with x, so this generates 10 points, and you will find these inputs, these values, now it's in the x value. Here it is. Now I generated a 20 point. The second concept we need to know, what if the inputs and the outputs now it's from the same 20 values. So do you see here, the default list generation here, that it match every input in X with the same input in Y. So now both of them has the same numbers. So we will find that the X and Y has the same. It's 4 and X, 4 and Y. And if you change it, any of these, let's say we can start from, this is the start. Now it started from 10. This is the step. And this is the count. What if Y doesn't have the same amount like X? So let's say if it's say 2 values, only 8 and 13. So this is the second concept. So the first item took the first output of this series, which was 10, and the first in Y was 8. Then from the second item to the rest of the list, all of them has the same second value. Okay, this is one of the default generation of lists you will find in Grasshopper. So in order to make both of them that you want to apply for all of the X, I want this value in Y, and for all of the other in Y on all of the list of X, you will find here this one called cross-reference. This component, the default is here, this is the Y, let's say this is the Y, shirt, enter, and here is the X. Now, it matched for all of the X values, all of them has the same Y, and all of the Y value, all of the other values at the other slider. So the default is, we call it the longest list. With the longest list, it means that the first item for the first two inputs will be matched together. And according to the longest list, the second item will be matched to the rest of the list. So this is just a basic concept. But also you can generate a grid, which is actually enough for this course for some reasons. So if I click a square grid, just a square grid. So this will have the inputs. It tells you what's the base plane. If you want to generate this grid on any plane, like a facade or top or any angle, but also you can use it as a kind of a starting point. So let's say I want to generate a grid in this, starting from this point. So I will click point, set one point, connect. So this means that there is a grid, start from this point. See what's the inputs. It tells you this is the step size. Let's say I will say 1.5. Automatically with the sliders, if you click 1.5, it will generate a slider with 1 decimal, and let's say from 0 to 10. So this is so this control the size for this number of the graded X and Y. Let's say this is X. And this is it. So the output of this component is just a grid, a curves. If you selected this panel, you can know what is this. It tells you that this is rectangles, and these are points. You can, with this point, you can also use this. We used this component only for calling data from Rhino, but also you can connect it. Maybe it helps you sometimes to make some actions or to connect this output with other components in your algorithm. So if you want to hide an object in and you don't want to see it in Rhino, right click. There is a preview. So now I hide just the components. Okay. Yeah, this is serious. Yeah, for range, just to know it. Okay. Range. So it generates a list. Start from a domain. It tells you the domain is, say, from 0 to 1. You can click on this input, right click, and say set domain. If you want a range of values, say start from 1 to 10. So we'll find here that it started from 1 to 10, and here it divides how many number of steps. Say 11. So this you can divide the whole range on some specific amount of steps. Also, you can make this one controlled if you set domain construct. So here's this is another component. It tells you from the start and the end of the domain. Here I clicked right click, set domain, and you write. Here I can make a slider. Let's say I start from 2 to 10, connect. So this means that I can control the start and of course the end and the values. And these just generate a list of values, and you can connect these values to anything. So let's say to draw a line, to draw a box, anything. So let's say I can make a click and say I need to generate a box, a center box. So let's say this is the center box. This box has different X, Y, and Z. You can, if you put or you connect this output to X, so this generated maybe you can here. So this generated 10 boxes or 9 boxes with different X values. So the X size, let's say I think it's 4 to the right and 4 to the left. So it's 8 in X, 8.5, and so on. If you make these inputs, so all of these items are generated from one base plane. So now I have 8 values. If I in the interface here, if I right click on the points, 2, 3, 4, 5, 6, 7, 8, sorry, 9. These are 9 points. You can select these components, point, right click, set multiple points. You can select them on order. So now I have multiple points. If I connected these multiple 9 points So the 9 values of the X and Y for these boxes will be matched to each object on this list. So this is the maximum. This is the start of the range. And this is how do you want to generate this. Now I increase, of course, with this division, I increase the amount of boxes. So it generates the first one according to this first point, the first point with the first value of X and Y. So this is a small box and so on. Then it reaches the 9, and from 9 to, let's say, 16 or 9 to 15, all of them has the same last point in the list. If you change it and increase the amount of these points, sorry, select multiple points. Now I select in order, but if you select it like this, maybe the order of these points, maybe it's a change. Okay. Now, just 2. Okay. So this is this idea of longest list. This is the cross-reference. Okay. Yeah, we will return back to this shortest list again. So this is the default. If you have, let's say, an input X and the input Y, if the input X has, let's say, 3 values and the input Y has maybe 5 values, so this means that it will make this kind of matching the first item with the first item, the second, and here it will connect the third value with the others. And this is for the cross-reference, that all of the values from one of the inputs is matched with the others. So now let's, before do this, do some parametric functions, and we will build one of the algorithms together. I think you remember last time when I in Mathematica, I think the last time we discussed this kind of implicit functions, where you evaluate each point in this space. So this is a 2-dimensional space, and in each point it has some values for X and Y, and you test each one, which of them has an output, let's say here, less than, okay, less than, let's say, 2. And this is the domain. You start from X from -2 to 2, from -2 to 2 in Y. And then this generates, this means that all of these values are less than this value. So how to do this in Grasshopper? You can do the same thing. So we will just make a square grid. Here is a square grid. Any amount of inputs in X, inputs in Y. We will look at the output of these values. Right click on preview. Now, we need to ask every point in this space a specific question related to its value from X and Y and so on. So now each if you looked at these points, it tells you in this panel the values of x and y and z. We can deconstruct. This is one of the components. It just deconstructed the values or the embedded values inside each of these elements. So let's say this is a point. Here is x, y, and z. So this means the first point has an x value 0. The second point, the third point, and this is only the x or the y. Okay? So this is the y1, y2, y3. So this means that if I was able to ask each of these values a question for, let's say, what is the square or the power of x. Let's see. We will use here and evaluate this one with this if function. And here you can write a simple mathematical formulas if you want to write. Here you can write the formulas in this expression input, and this is the input of x and y. So let's say I would like to test the x the power 2. Well, it's just the y because the first was okay. So now you will find that this is 0, 1, 4, 9. So now the output is just the power of x. What if I would like to x squared and plus y squared? Now, of course, it's null because the y is empty. There is no inputs. Now this is the output of x squared plus y squared. What if I ask it that is it more than, let's say, this output, we call it a Boolean operation. It's like a 0 and 1 or true or false. So now each point, so these points, the output of it's x squared and y squared, they are not bigger than 4 and so on. So let's hide these points. I need to hide some points that has the results false or true. So I will say here, one of the components called cal. We will use this cal pattern. With this component, you select the inputs and you say what is the pattern, and almost usually all of these patterns means that it's a true or false or 0 and 1. So if you connected this, and let's hide. Okay, so now this means that all of these points, this is the bigger x squared plus y squared is bigger than 4. Yeah, I think I just explained. And the interesting thing, of course, in this graphical algorithm that we very basic thing we built. Of course, if you went to any of the inputs, you changed the number of x and y. If we change this point, so let's say I would like to start from, let's say, this point. set one point, connect. So this is, as you see, that this is a circle. Okay, you can change the step size. Now the output for this function is a true or false. You can right click and say invert on this input. This means that what was true will be false and so on. And also you can do this on a 3D object. So this is one of the basic algorithms now we did. I will save the file, and if you are the first time for you in Grasshopper, you just need to save the Grasshopper file and the Rhino file, each one separately. So here I will just save the Grasshopper file, save. Okay. So this means if I closed the Grasshopper is saved, it will ask you another question for the Rhino. So now this is the name of the Rhino file. This is the name of the Grasshopper file. Okay. Just one moment. Yeah. Okay. So these kind of complex elements that you see here, all of these has the same idea, but we didn't ask a 2D grid. We also asked it a 3D grid, and with complex equation. Okay, of course, our course will not deal with these kind of things. We will draw our designs, and machine learning components algorithm will do the rest for these things. But just to understand the maximum of these tools. So if I will, I think here in Mac window. So this is what we did, and you can generate with this complex surfaces. Just you increase now it has another basic components just to generate a 3D grid. So let's do it now. Right. New document. So I will start from the beginning. This is a square grid. Square grid. Oh, sorry. Oh, I think it's here in vector square grid. So the basic idea now, we have an output of a 2-dimensional points. How to generate a 3D. So here you can make this kind of copy by one of the commands, move. You want to move object from a position to another position. So this component move as the inputs are geometry and the vector. So I will just test it before doing this 3D object. Here is a points. Set one point. If you want to move it, let's say in X or Y or Z, if you double click here and click just X, you will find one of these components are for the vector of X. This is X. icon. Also here from vector, you can find, this is the fourth menu, X, Y, and Z. So this is, let's say, X, Y. So the vector, you can make an input of a slider, and this is the vector. So by that, you are able to move a point from a place to place. If the inputs of this slider is zeros, this means that there is another copy of the same points, didn't move it, it's on the same position, 0. This is what we will do it here also for all of this. So what happens if all of these grids, now here is the inputs, and now you can move it in X, or Z, and the same basic idea. What if we have two sliders? Shift, and connect. You remember this problem of this longest list? So the first maybe elements on the x-axis, now it's all of them has the same slider. But also there is something very important we understand. You will find here that this connection, one of these connections of this wire, it's black and continued. And this is just a kind of a dotted wire. So this dotted wire means that it's not only contain a list, it's contain a list of lists. So some of these outputs are generated as like this. In Grasshopper, we call it a tree. So the first points on the X value, all of them has these 0, which means that all of these Y, this is on the Y axis, all of them are the first. It starts from 0, 1, 2, 3, 4, 5. Then the second column, you will find here it has kind of another name. And here you call it another path. So this is the first path for the first column. You can make a kind of, we call it a flatten. Flatten means that all of these sublists are be union in one list. For doing this flatten, you can flatten tree. This is a component for flatten. The output is that all of these lists are all now one. So this means that the last element here, this is the following one. Some of the components also you can right click and say flatten. You can do it like this. So this means the same. So you can use it as a component or right click. So for this idea, we can make we can make this flatten. Now we need to build for each point other points on the Z level. So we will use also the same component of this let's say series. So let's say we have 10 values from 0 to 10. if you connected these to this output, the first point will be moved on 0, the second point on 1, the third point on 3, 4, 5, but we need this for all. So we will use another idea called, it's the invert of flatten, called, here they call it a graft. Graft means that each element is a list by itself. They are separated, they are not the same. And this means for this component that each element, is all of these are one list. And here there is many lists. So the output of this component will be generated that for each element of these points, it will apply this value on it. Let's say on moving it on the Z level. So let's see what happens. Now each point will be moved separately on the Z level. So by that we generated a grid of points. So just to review it quickly, a grid, this is a points. Here I made a flatten that all of points, there is no division of these columns and rows, all of them are sorted as a series of points. And here I generated some values and made the opposite of this flatten, that it's a graft, because I want this component to deal with each of these values separately. And then the output of this is move. You can hide, right click, select, just click and drag, right click, unpreview, and this is a preview of 3D points. And still, if you want to increase the amount of points in X, Y, so now you generate a 3D volume. For the Z, it will be connected to this part. So I want to increase the amount of values. So this series started from 0, step size 1, and this is the Z, let's say, now you can increase the amount of the grid. You can start from any level. This is the start. Of course, you can use some sliders for both components. Let's say 2. This is the size of the grid in X and Y. And here's the size, the step size of these values. Then we have these points. Now let's see how it's generated. Now, say you will find here that there is, or just will decrease the amount of these values, then we can see it on the list. Save. Just a few of them. Then you can find here how it's separated. So let's say the first 36 has the value Z. Then the second level 36 values has the second value of Z. So this is the first, the Z is 0. If you went to the second list, the Z is 2, and so on. So let's try to have just few amount of these values. And then let's also flatten, just to deal with all of the points without, so the output of this, there is no separation of levels, so all of them are the same. And now we need to ask to deconstruct the same idea. You need to deconstruct the point. Here you will find later, okay, you say you want to deconstruct a curve or a surface. So this is to deconstruct the point to the values of x, y, and z. Also, you can make a function. Sorry, evaluate. It's here. It's called evaluate. This one. And in Grasshopper, if you zoomed some components, it accepts that you can add more values in inputs and outputs, like this function. This one that it doesn't have. So here I only need 3 values for x, y, and z. And then you have a function, you can write it. For this component, you can select a panel and you write as we did before, or you can right click, and you can write it here on this input expression filter. Yeah, it has some components or some constants like pi, epsilon, if you want to use this. Okay, but let's say if we try to make, what is the, say it's x squared the output is true and false for each point. So just I will change a little bit the starting point of the grid. So here is a parameter point, select one point, this one. I will connect it to this input of the grid. Now it's moved, so I can move the grid. If you want to move it on the Z level, we can go to the front. So here is the 0 level. I can place it down. So this means this is the Z value. Okay, let's go to perspective. And let's hide some of these points and show the others. So this is the one that you want to apply this pattern on it, true or false, with this pattern color. The inputs is the points. So you have to go back to these steps. So let's say this flatten object, and this is the true and false. So at the moment I will just hide. You will find here that there is a pattern already default in it. So I will connect this. Just let's make an invert. Okay. Just to see. Okay. This is, yeah, something small. It's 30. And this is actually it's a sphere, like the circle, but this is a sphere. Here I change the size. Now there is a half a sphere because the grid now is smaller. If I moved the grid from these points, so all of this we deal with points. This kind of organizational logic of points you can later think about how to, let's say, draw lines or curves, or you can generate boxes. You can build a box, say center box. So the output now for this, the input was the points and the pattern. These are points. You can put these points in this component, and you can manipulate later the X, Y, and Z. So say X. Okay, it's 0.5. I think the grid size is 1 in the X, Y, and Z. So here, if you applied 0.5 for each point, this means that it's 1 voxel or one box for each. For each point in this space. Okay, there is another idea. Now from a couple of seconds, we flattened these points, but there is sometimes an importance if you do not make this kind of flatten. So this means that if I use the older points, it's generated like in each level there is some points. So maybe this is later helps me to generate a kind of a contour, separated contours for each level separately. So this is the important thing, that I preserve this lists and sublists or arrangement. But here it's a flatten, so you can't easily separate the Z because they are all the same with this one. Okay. So now, what if I would like to see only the first point, the first level? So we saw here this one. You see, now there is some lists here in some levels. If we solve the points, so the box is within it. So here's the first level, second, third, fourth, five. It's empty. There is nothing. So this component saved these empty lists, and then it starts from another level. Say it's 7. So this means this is 0, 1, 2, 3, 4, 5, 6, 7, and only you have few amount of points. Okay, so how to get any of these, we call it branches in Grasshopper. So say the first branch, the second branch, the third branch. So you can do two things here. If I say here, I can say this explode tree. With this, you can take any of these parts. So all of these are empty. So these are empty lists. Nothing. So if you put these points, this means that you only will generate only a level of this list. Just I hide this, and I will hide, right click, hide. So this is only one of the levels. Okay, but maybe sometimes these levels are lots. So I want to pick one. So we will use here a tree branch. This one. You can select this one. Okay, here's just an error. You will know why. Of course, for all of these errors, it tells you in this kind of a small balloon message, it tells you what the error is. So now what's this component try to read? It read the path and it read this name specifics like 007. So it has a specific name. Okay, this panel just to show you the names. So by that I got the names and some information about this list. This is a tree parameter viewer or tree viewer. So I would like to get a specific element from the list with its name. If you want to pick one element from a list, this means that you need an item. You get a list item. List item, you just make an input of a list. And this is the index. Let's say. So this means that the output you need only the name of a list. And this component you can also use it with any of these parameters or these parameters or components we use. That you have a list and you need a specific item from it. So now I need only this one. So just for a preview, we will decrease the size of these elements. So this is just to see the tree, and here to select just the name of the tree. If you clicked like this, sorry, so just. So now I selected only one of the branches or one of the sublists with this name. Maybe this is level 11 in our components. So if you used this means that I can go through any of these if you change it. So by that, you go from any of these levels to the other. Okay. The last thing that is important just for me for this course is now I generated these things, but now I want to export it to Rhino, then I can export it to any CAD software. So if you will click on any of these outputs, right click, you can here called bake. If you clicked on this, it will export the model as a 3D, because at the moment you cannot select anything here in Rhino. Right click, bake. It asks if you want to export on a specific layer. If you remember these layers, you can click on any, say this is the default. Right click, bake. Okay. So now we will find these elements here. You can shade it, review. Okay, so this is an output, how to export this. So with Grasshopper, here you start from input, like this, like the point that was here. And then this is the output with bake, and that's it. We don't need something more than this. From the next step, from the next lecture, I will send you a plugin that we will only have some basic algorithms. Let's say it will be something like this. We will understand one component or two components, and you will have some inputs, which is your designs, just to draw it in Rhino. And you will get an output. Right click, bake. We don't need anything else from Grasshopper for this course. I just today just a quick navigation with it, just to understand what is the parameters, what is input. Yeah. By the way, what I did is just I make a kind of, it's called a cluster. You select a couple of components and say they are a lot. I need them to be one object. That's right click, cluster. But you don't need any of these. So that's it for today. We don't need anything else. For the next step, we will deal with some basic idea of machine learning. Can do this with these functions that we did. You can do one of these neural networks, simple components from the next time, and with some basic files I will send you. You will use it. It will be easy for you to do. So okay. So see you next time.